Good day, everybody. Day 4, continuing the difference of 2 with the difference of 2 square, another factorization strategy. So we looked at the HCF method 2 days ago. Yesterday we looked at grouping, and today we look at the difference of 2 squares. What do we hope to achieve today? So firstly, of course, we have to be able to recognize when to factorize using the difference of 2 squares, and we also need to be able to factorize using the difference of 2 squares. And the first one is very tricky because this is one of those strategies or one of those questions where disguise is usually a given. They hardly give you this explicitly. Usually you have to be able to identify it. So how do we know when we use the difference of 2 square, or how do we know when we have to use the difference of 2 square? This is something that should start raising your antenna. So once you see two terms, like two different terms, most times, more often than not, that's how they're presented, and they are being subtracted from each other, that should start sending a signal. One or both terms will be either squared, and if not, that simply means that it can be written as one. It can be written as a square. And sometimes it is already written in square terms, but oftentimes it is disguised. So not all the time they will give you. Here we have a common example. So 5x squared minus 5 squared. And you see, this is what this strategy means. This is the difference of 2 squared. So the strategy tells you the name. But as I said earlier, this will not always come like this. More often than not, this comes as a disguise. And you're going to see that as we do the example. So here we have, they ask us to factorize. And again, we have the difference. Today we are emphasizing on the difference of 2 squared. Be careful though, I expect you to be open-minded. Good. So in a case like this, notice we do not have the difference of 2 squares, at least outright here, but we could, because we just have to apply a simple change to the 25, and that's what we had a while ago. So this could be written as x squared minus 5 squared. Note 25 is the same as 5 squared. When written as 5 squared, now we have the difference of 2 squared. This is the same as x minus 5 all squared, which in turn is equal to x minus, well, plus 5, it doesn't matter, well, x plus 5, and then we have x minus 5. And that's it. That is it. Easy does it. Yeah, it's one of the easy strategies, one of those that I like the most. But I guess it compensates in difficulty if you are able to recognize that it is a difference of 2 squared. Let's do the second one. So the x is the only one that is squared here. And it might seem as if, okay, the minus 1 is just whatever. But this is one that throws off a lot of students, because a lot of students seem to fail to realize that 1 is also the same as 1 squared, which makes it eligible as a difference of a square at least. Here we have x squared, and I've seen students left the 49 just like this, but that is a problem. For it to be the difference of 2 squares, it has to be actually showing the difference of 2 squares. 49 is not a square. But when we have 7 squared, now we're dealing with differences of square. So these first two here could be written as 7x all squared minus 1 squared. And ultimately, that is the same as 7x minus 1 and 7x plus 1. That's it. That's it. As I said, it's one of the easiest strategies, but of course, sometimes it varies based on understanding. I think the simplicity of solving this is subsidized by the difficulty of recognizing whether it is a difference of 2 squared. Because once you could recognize it, the rest is pretty much a walk in the park. So as I said earlier, disguise when it comes to this one is a big deal. It's a major deal, right? So here we have 4 different ones I would like you to attempt, of course. Here you could pause the video and see if you could do them on your own. I would not pause, I will move on speedily. So number 1, when we kind of did a replica of number 1 just now there. So for this to be a difference of 2 squared, we just have to do a little changing up. So 25, remember, is the same thing as 5 squared. Then we have x squared. And 4 can be written as 2 squared. So this is evidently the difference of 2 squared. So this will give us what? Let me just write it a little nicer. This is the same as 5x minus 2 all squared, which in turn will be equal to, allow me to write it below here, 5x minus 2 and 5x plus 2. And again, believe it or not, if you go to fall this back, if you go to expand this, you will end back with what you started with. This here will lead to this. And I will prove all that in time to come. That's just not my focus for now. Here, let's fix this to make it look like the difference of 2 squared. So 144, I know that will be 12 squared, because 12 times 12 is 144. 9 is an easy one, that's 3 squared, and the t is already squared. So now we have the differences of squares. So that will be the same as, if I may jump straight to the answer, 12 minus 3t into 12 plus 3t. And that is it. That's it. So once you write them in square terms, the rest is pretty straightforward. The rest is just a matter of understanding what's plus and what's minus. And that's really it. That's the bottom line behind it. Right? So take note of that. This one here could also pose a little, I don't know, it could trick a lot of people, but it's really straightforward. Because, well, not really, because if you never met it before, it will be hard to see. But in this case, we have to see the a plus b as a term. Yes, I know, however hard that is to believe, we have to see that as a term and not as two separate things. And the 36, of course, you could do a little fixing up there. So here, the first term, which is a plus b, is already squared. So we leave that there. But the second one now, we have 6 squared, because 6 times 6 is 36. And now we could apply our rule with the difference of 2 squares, and this one will look something like this. So we have a plus b, which is a term, minus 6. Good. And then we multiply that by a plus b, which is the same term again, plus 6. So it's straightforward if you understand it, but if not, again, this one comes with practice. Sometimes I would say this is also one of those disguises that tends to happen with the difference of 2 squares, because it's kind of hard to see a plus b as one term, but that's what it is. If you try to expand it, you will end up with something very much complex, and then you might deviate from actually the difference of 2 squares. And oftentimes you just have to state it. At this level, we don't have to be able to solve it right down to end up getting a solution, but that's just what it is when it comes to the difference of 2 squares. And this one, number 4, I could imagine how much of us try to hurt our head to figure out what square could give us 6. So clearly we could see the 16, and we could say, okay, 4 squared is 16, but what can we square to give us 6? Well, as far as I know, nothing. So this is another one where I think I hold most of you. So for this one, we just had to use the HCF method, with the common factor being 2, of course. And 2 could go into 8, 2 could go into 16. 8 times, that brings back down the 8 squared minus 3. And yes, this is the solution for this one. And that's where we need to be careful. That's where we need to be careful. Because you see, sometimes the question looks as if you can apply the difference of 2 squares, and everything might seem to lead towards doing the difference of 2 squares. And this is one of the things I was saying from day one. When you know all the strategies, this is what could become cloudy. This is what could become technical. So you need to know your strategies and just know what could be applied. Don't try to make up a number to square to get 6, because you cannot get it. And if you do, it would not be a real, no, it wouldn't be a real number, but it will be a rational. And those are very hard to get, right? But that's how you go about finding those, factorizing those. So today, Thursday, tomorrow, Friday, what I think I would do, instead of looking at the AC method, we're going to take some practice with the first 3 strategies, so that at least we could see how tedious it could be that when you know the 3 of them is not just a matter, well, not well, for now we know 3. By next week you will know 6. But when you know the strategies, one of the main challenge usually comes in knowing when which could work. So you have to be very cognizant of that. So for today, we're going to wrap up on that. Again, as always, feel free to like, share, and subscribe. And until the next time, we'll continue with some quadratic factorization.